Okay, so hello guys. So I wanted to make this video right before we get into basically I wanted to study functions. One of them is going to be linear functions, and we are going to be doing just kind of a very brief because I've already done a lot of examples over like linear equations and all that good stuff. I do want to go over how to graph linear equations in where, or linear functions in where you're given the slope and the y-intercept, or slope-intercept form. I know I went over this like a really long time ago, but I want to just make sure to go over it again, and this is, I guess, an updated video over that. So I'm just going to go over one simple example, and I am going to use the definitions of slope and y-intercept to basically do this problem. So right before I get into it, actually, I am going to state what slope and y-intercept mean. So the slope, when we have a graph, and I'm going to go ahead and just draw this random kind of line on the graph here, and I'm gonna say, so for example, this is, let's call this x1, y1, right? y1, and then over here we'll call this, and we'll call it x2, y2. Okay, now the slope of a line means that it's however much we're rising here, and then however much we're running here. Actually, it'll be approximately, it'll be approximately like right here, kind of. So just this basic definition means that it's going to be however much we're rising. So this is considered, the y-axis, right? So this here can be determined by the change in y. So the change in y means that we're just going to have the following, and let me write it down. So change in y is going to be, it's going to be y2 minus y1, right? Minus y1. And then the change in x, so the change in x will be x2 minus x1 minus x1. Right? And so that is the idea of slope. That is called rate of change. You can also call it rate of change. And when it's a constant rate of change, it means that it rises and runs every time by the same amount. So like the line y equals x, if you kind of see y equals x, and you see here we have like 1, 1, 2, 2. And what I mean by that is that when you make the table, the rate of change is constant, meaning that it keeps adding to 1 on both. Well, actually, yeah, well, it would be on both sides, but mostly on the y term, right? So and also y-intercept. Y-intercept just means that it is a point on the y-axis. So y-intercept is a point on y-axis, and it's of the form 0, y, or 0, b, right? Sometimes they'll call it y equals a number. So like they will say the y-intercept is y equals b. So like that would be when you have the slope-intercept form. And I know I'm saying a lot of things here, guys, but I know this is very important because these are the basics of algebra. So it's y equals mx plus b, mx plus b, and m is the slope, and b is our y-intercept. So using all these things, right, and I want to just kind of, that was kind of a brief definition. I went over it very fast. If you guys do want me to go over more of I do have other videos that talk about it in more, like, just in better definition, but that is basically those definitions are the ones that we have to use to graph this, right? So, knowing that the y-intercept, so the first thing I look at always is the y-intercept. And I know that this is y equals x plus 1, so I know that y equals, and there's like an invisible 1 here if you think about it. So it's 1x and then plus 1, right? So if you think about it, this is already of the form y equals mx plus b, right? Plus b. And so we just went over this. We know that the slope is m, so this is the slope, and b is our y-intercept. Now, again, the y-intercept just means what is y? What is y when x equals 0? This is what the y-intercept means. So if we plug in 0 for x, let's say y equals x plus 1, right? So let's do x plus 1. And if we plug in 0 for x, so x equals 0, we get y equals 0 plus 1. So 0 plus 1, y equals 1. Another way you can look at it is, this is the y-intercept. It's y equals 1. Or b, it would be at 0, 1, basically. So you would plot it right here, and that is the y-intercept. Now the slope of this line is 1. Now again, the slope of a line is, and this is another definition, it's rise over run. Rise over run. So for example, if my slope is 1, I know that basically I have a slope of 1, and I know this equals to 1 over 1, right? This is basic arithmetic. We know that it's 1 over 1. So I know that for my rise, I'm going to put 1 here, and for my run, I'm going to put 1 down here. So then so that means I'm going to go up 1. So I'm going to go up 1 unit from the y-intercept, so up 1, and then over 1. And that'll take me to the next point. And then from there, I'm going to do it again. So up 1, and then over 1. And that'll take me to the next point. And then again, up 1, and over 1. That is the idea of slope. You're rising however many units it goes on the top. So up 1, and then however many you're running. And then for the when you're doing the opposite, so basically you keep going until you finally reach a point where you can't go any further, right? In the positive direction or in the right. So then what happens is we now have to go, so I know also that my slope is 1, and I also know that to complete this, it looks like a line, right? But it's reflected over the y-axis, or it's reflected, I think, like about the origin, kind of, or about the point 0, 1. So basically, we're kind of doing a reflection across the y-axis. So what I'm gonna say is that my slope can also be -1 over -1, because this is the same thing as 1. But now we're going down 1 and left 1, because we have to do a line. we can't go up one, left one, because that just wouldn't make sense. It has to look like a line. So it goes down one and then left one. So and so it'd be right here, and then we just keep going. So down one and then left one. So it'd be like right here. And then you would just keep going. And you kind of see a pattern of like, you know, you just go down one, left one, down one, left one. And finally, until you can't go any further, that is when you know that you've completed the how does it go? The line, or you've plotted all the points that you could, right? So now the idea is that we can go ahead and finally just trace a line through the points. And by the way, guys, although, you know, I did not want to really go over parent functions, but basically, one of the parent functions for this, you know, the parent function that goes with this equation of y equals x plus 1, the parent function is y equals x, meaning that it's literally a line that goes through the origin, and this is where the slope is 1. The y-intercept is 0, or 0, 0, right? Right. So, and for the domain and range, well, we can put anything for y and x. There are no restrictions, and like I said previously in the previous video, we went over interval notation. So the domain is really, because if you think about it, it can go forever in the left and right, and also it can go forever above and below the x-axis. So our domain is from negative infinity to infinity, and our range is from negative infinity to infinity. But this is where I'm going to stop the video, guys, because I don't want to go more in depth. I don't want to make this video way longer than it needs to be. But that is kind of how you, this is how you just graph this linear function. In the next video, I am going to go over one where there's a, where we're going in the negative, like instead of it being, you know, positive x plus 1, we're going to go negative, and you'll see exactly what happens when I do that. So with that being said, guys, thank you so much for watching, and also please like, comment, and or subscribe, and I will see you guys in the next video. Bye, guys.